In this supplementary video we demonstrate two application scenarios for the sequences generated by our optimization method. We first show how the stable assembly sequences R method provides a helpful in AR-assisted assembly. Our application runs on a Microsoft HoloLens 2 mixed reality headset, which allows the user to visualize the assembly sequence in mixed reality, while having the hands free for the actual assembly process. The user can interact with a virtual button to bring up the next bar in the assembly sequence, which is then shown in cyan and slightly pulsing. The process can then be continued until the structure is complete. Because the assembly sequence takes steps with high stability, it is easy to align the bars with their virtual counterparts without the need for external tracking. This improves the assembly time and reduces the margin for error. As a comparison, we assemble the same structure, but this time using a random feasible sequence instead of the optimized sequence. As can be seen in the video, the misalignment between the built and planned structure makes it harder to interpret where a bar should go and how it should be aligned with other bars. Even though the user can still assemble this example, it is not a given that a general structure without compliance optimization can be assembled at all by a single user, as deformations can either make it impossible to simultaneously support and assemble bars, or lead to damage in the structure. In the second use case, we show that our multi-bar at a time assembly sequences can readily be combined with robotic motion planning for efficient digital fabrication. Again, we generate assembly plans with high structural stability and small deformations throughout the sequence. We then plan the robotic agent's motions according to the optimized sequence. In future work, it would be interesting to explore the possibility of more closely integrating the sequence planning with the robotic motion planning, to generate feasible and safe sequences for arbitrarily complex structures.